So write equations of motion. Equations of motion. Equations of motion. Okay. So first, before going to start, some statements I will write. I will say you. So please write that. So remember, these equations of motion only we will write when the body is having constant acceleration. Do you understand? So today, maximum will try to study all the three derivations. So perfectly, we'll study with the help of graphical representation. Kindly focus. Anywhere, if you get any doubt, you can ask me. Easily yourself you can solve, because till last class we found how to find the distance, how to find the displacement, how to find the acceleration. You all done or not? Yesterday's numericals. Yes.
Yes, sir.
If you know that, today's class is very simple. Deriving. So equations of motion, right? When a body is moving with a constant acceleration, some statements actually, that is what, when these equations of motion will apply. When a body is moving, with constant acceleration, then the motion of the body is known as, what is that we can say? Constant acceleration. Accelerated motion, or what? Zero acceleration. When the body is traveling with a constant acceleration. What do we say?
Zero.
Zero, Amari.
Zero.
Sir, uniformly
Constant acceleration
accelerated.
means uniformly increasing velocity. Means what is that? Body is in accelerated motion or not? Yes or no? Constant acceleration means velocity changing uniformly. So then body is said to be accelerated or not? Everybody?
Yes, sir.
Yes. Then
Yes,
the
sir.
motion of the body, is known as uniformly accelerated motion.
Good morning, sir.
Good morning, Shailesh. Please focus on today's class, Shailesh, till last. Okay, it is very important. Any doubt, ask me. Right. In
Okay,
this
sir.
case, the relationship among the velocity, displacement, relationship among the velocity, displacement, time and acceleration, of the body is represented with the help of three equations. With the help of three equations. These equations are known as these equations are known as equations for uniformly accelerated motion. Uniformly accelerated motion, or simply you can say equations of motion, your choice. But you remember, whenever I say equations of motion, these equations are applicable only for what? A body is said to be in what motion?
Uniformly accelerated motion.
Accelerated motion. Equations of motion, we can say. Clear, everybody? That is what, right? First equation of motion, we can say velocity time relation. What is the first equation of motion we used to call as? Velocity time relation. All of you remember that. Velocity time relation. first equation of motion. First equation of motion also we can call it as what? Everybody? Velocity
Velocity.
time relation. Okay. So first equation. V equals to U plus AT. What is the first equation? Everybody read. V equals to
U plus
U plus AT. V equals to U plus AT. First equation. Clear? So can you tell me V means what? V means
Final distance.
final velocity. What, Mari? V, velocity, correct. U means
Yes, sir.
initial
velocity.
velocity. Next, A means what?
Acceleration.
Constant acceleration. Clear? Because have you noticed it? Agalya, moving with what acceleration? Constant acceleration. Clear? Time means T means what? T means what, guys? Time taken. So what is the first equation of motion? Everybody? V equals to, please pronounce. V equals to U plus
80.
AT. Next, second equation of motion. So first equation,
Sir, what is this, sir?
which one, Mari?
This one, first equation of motion.
V equals to U plus AT. That is the first equation.
To find the final velocity.
Find the
yes, sir.
velocity time relation. This is velocity time relation. Okay.
Sir, in velocity time relation, we are finding the final velocity.
We can find
yes, sir.
final velocity, we can find initial velocity, we can find acceleration, we can find time. Anything we can find in this. Okay.
Yes, sir.
Yes, everybody.
Yes, sir.
So first equation also we can call it as what? Everybody. Velocity time relation. Keep it in mind because you are going to use in future like this only. Velocity time relation. By this time we should say. Is it okay, guys? Yes, that is. Next. Second equation of motion. Second equation of motion. Or we can say displacement time relation. Displacement or bracket you can remember position. Sometimes position also there. Time relation. Is it okay, everybody? Yes, please. All of you?
Yes, sir.
Equation is, speak along with me. S is equals to, respond. S is equals to ut plus half at square. How to read, everybody? Read. S is equals to ut plus half at square. Please remember. Read, everybody. S is equals to not, don't read 1 by 2 at square. And the madri kadayad. How to read? S is equals to, everybody. What is that?
T plus half ut square.
Yeah, S is equals to ut plus half at square. Understand? English?
Yes, sir.
That is.
Yes, sir.
Yeah, please make it. S is equals to ut plus half at square. See, U means initial velocity. T means time taken. A means constant acceleration. Again, T means time. That's why I'm writing only one unknown thing for us. What is that? S means what? S means
Displacement.
clear. That is what. Next, third equation. So second equation
Sir,
also.
one doubt, sir.
Yes, Mark.
That at square, the squares for both A and T.
Only
sir.
for T. Only for T.
Yes, sir.
Only for T. Clear? S equals to ut plus half at square. Clear? All of you? Understood, Amma?
Yes, sir.
Yes. Next. Next. Third. So second equation also we can call it as what? Displacement time relation. Third one. Third equation of motion. Third equation of motion, also called as displacement velocity relation. What is the first relation called as? Displacement also we can say position. Position velocity relation. What is the first one? First equation, another name? Everybody?
Time relation.
Ah,
Time relation.
velocity time
Velocity.
relation. Second one, displacement time relation. Third one,
Displacement velocity relation.
displacement velocity relation. Have you noticed it? So third equation, read along with me. V square minus U square, V square is equals to U square plus 2AS. Or you can say V square minus U square is equals to 2AS. So both are correct. Any one thing you can write it, your choice. Just and nothing. This U square is in plus. Will come this side. What will become? Everybody minus. That's all. Or some people basically write like this. 2AS is equals to V square minus U square. V means what, guys? Final velocity. U means initial velocity. Ellame theriyuma? Yes, please. Respond.
Yes, sir.
So these are the three equations of motion. What are the three equations of motion? Everybody tell me without mistakes. Yes, please. Three equations of motion. First equation of motion, fastly.
First equation of motion
Yes.
is velocity time
Yeah, what is
relation.
that? What is that? V
Time
equals to
E is
U
equal
plus
to U plus
U plus
AT.
AT. Equation one. Second equation, S equals to UT plus half
Plus
AT
half
square.
Half
Third
AT
equation.
square.
Third one, V square
U
minus
square
is equal
minus
to
U square is equal to A 2AS.
Okay.
Sir, that
Unless
A is.
Mari.
So what is that? Yes, sir. Yes, denotes what?
Yes means displacement, Mari. Just now we have written up correct.
Sir, yes means we'll write upside arrow no, sir, vector.
Okay, but I'm saying you 2AS. Leave it. Yes means displacement, you remember. Clear? Of course, distance also, Mari. Okay, yeah. Distance or displacement, Mari. Okay, wow. But actually, it is what? Constant acceleration. The body, these equations, only we can use it for what? Uniformly accelerated motion. Understanding? So that is why that S must be what? Distance or displacement? It must be
Displacement.
displacement. That is why. So three equations of motion. Everybody 2 times try to memorize and do it. Then we will derive derivation of equations of motion. We'll go with that. Please, everybody. If you are clear, then I will proceed. Ellame clear? Yes, Ra? You should remember, you cannot forget these three equations of motion. And these three equations of motion, we are going to solve first graphical method in our today's class and tomorrow's class by algebraic method. Both will study. Is it okay, Mari? Sanjay, Lingesh?
Yes, sir.
Yeah. Shivani, understood, Shivani? What are the three equations of motion? Tell me, Shivani.
V is equal to U plus AT.
Second one, S equals to
Displacement is equal to UT plus half
UT plus displacement illa
square.
S equals to UT plus half AT square. Next,
2AS
yeah,
is equal to V2 minus U2.
V2 minus illa V square minus U square. V square minus
U
V
square.
square minus U square. Clear, everybody? So once again, I will say that reading is very important. V equals to U plus AT. S is equals to UT plus, Mr. Silesh, speak with me. S is equals to UT plus half AT square. S is equals to what? UT plus half
Half AT square.
AT square. V square minus U square is equals to 2AS. V square minus U square is equals to 2AS. Is it okay, Wah? Everybody?
Yes, sir.
Yeah. Yes, sir. Ille. Now you speak, Silas. I will see. Read. What are the three equations? Read, Tambi.
There are three equations of motion.
Read that.
to
I'm
U
saying you to ask you to read. First equation what?
velocity into
Velocity into
U
read exactly what is there in the first equation in the screen. You cannot either see the screen.
V into U at U plus at.
Ray, see that at least into is there, V into is there. See the mathematical tool, Ray. What this is? What symbol is there here? Huh? Is it into? What was Shailesh? Is it into? What symbol it is?
Equal to
Equals to. Read. V equals to
B equal to U plus
U
R
plus AT.
S
U plus AT. V equals to
U
U
plus
plus
AD
AT.
or some
AT.
UE.
AT. V equals to U
Yes
plus
equal
AT.
to
Okay. Second equation read. S equals to
S equals to
UT
UT
plus
plus 1 by
plus
2
half AT
AT
square. Ade 1 by 2 you cannot read. You should read it as a half AT square. How to read? Half
half
AT square. Half means 1 by 2 only. Half AT square. Clear?
sir.
Read S equals to
S is equal to UT plus half
AT
AD
square.
square.
AT square. Very good. Third equation read. V square
V
minus
square equal
U
minus
square
U square
is
equals
equals
to
to 2AS.
2S.
2AS. 2AS. Clear? So, what do you mean by A here, Sailesh? A means what? Acceleration. What do you mean by
Acceleration.
acceleration? S means what? I told you S means just now. What do you mean by S? S means what? Displacement. What is that?
Displacement.
Displacement. You should read. Okay. Next. Here, V means what, Sailesh? If just everybody wait, because I want to make him to read. Okay, guys. Others. Yeah, V means what? Final velocity. What is that?
Velocity.
Final velocity. Yeah. U means what? U means what? Initial velocity. What is that?
Initial velocity.
Okay. Wherever you see this, same terms. Understanding? So here you are seeing V. V means again what? Final velocity. Here U means what? Initial velocity. Are you writing the notes or not, Sailesh? Say the truth. Really? Yeah.
Writing notes, sir.
Writing
Sir.
notes. You speak. Speak only it will come. Simply sitting it won't come. Sorry?
Yes, sir.
You have to speak always. These equations of motion, again, I will ask you in the tomorrow's class. You should speak. Sorry?
Okay, sir.
Okay. So practice it. Okay. Shall we proceed, guys? All of you keep heading. Derivation of equations of motion. So we can use two methods. First method today we will solve by using a graphical method, and tomorrow's class by using what method? Mathematical method, means algebra. By using what? Algebra. Okay. Equations of motion. Derivation of equations of motion. So today's class we are going to study by what method? By graphical method. Okay. From the graph. So shall we proceed, everybody? Are you all ready?
Yes, sir.
Yeah. So for deriving graphical method, let us consider, right? Let's consider a body in uniformly accelerated motion. Uniformly accelerated motion. Can you tell me, Sailesh, Sanjay, how the graph will be? Uniformly accelerated motion. Who will say? Lingesh? Girl say?
Sir.
Agatha, Shivani?
Sir.
Yes.
Sir, the line
Right, sir.
Parallel to x-axis.
Yeah, parallel to time axis. Not parallel, Mari. Ayyo, everything gone wrong. It is
Sir,
uniformly
the line,
accelerated motion. Yes.
the line
Starting
will be two times.
inclined to, yes, straight. It is
Sir,
a
I
linear
told
graph.
linear only, sir.
Yes, Mari, you said parallel to x-axis. Parallel to
Sir,
x-axis is zero. Zero. Okay, it is inclined to time axis. Understand? That's fine. Okay. Uniformly accelerated motion, and keep it in mind. Starting from the position A, I will a graph I will show you. Starting from the position A with initial velocity V, with initial velocity V. Mari, can you tell me from this either the initial velocity of the body is 0 or already body is having some initial velocity? Let me see. Yes. And after time t, Anybody can tell? Silesh, Sanjay, for you. From this statement, tell me.
Sir.
Body is starting from position A with initial velocity U. Means body is already having
Zero,
initial
zero.
velocity,
Rest is
or
there.
it is starting from 0. I want to know.
Starting from 0.
If it is starting
Sir.
from 0, then I say it is starting from rest, correct? I am saying already it is having some velocity. Do you all understand, Mari? I am saying it's already with some initial velocity U. Means body initial velocity is 0 or not 0? That is what my question.
Not zero. Not
Not
zero.
zero. Understand, Mari? It's already having some initial velocity U. It is not starting from rest. Understand?
Yes, sir.
Time
Yes,
t,
sir.
and the velocity of the body is V.
Sir.
And the,
Sir,
yeah, please, Silesh.
sir, the three equation I didn't write fully, sir. 1 minute score means I will write, sir.
Why, boy?
Sir, two equation only I write,
Right.
sir.
The velocity of the time, the velocity of the body is V. Write it. Okay. So
Okay, sir.
write it fastly. I want to teach why write it fast. You have to be very active, Silas. What is this? Always very, very lazy. Huh? Okay. Completed, Rakishore. Lingesh.
Yes, sir. Completed.
Kishore, any doubt, Kishore? Nivedan?
Sir, no.
Gokul Raj, Mudinja Gokul Raj. Sangamitrai. Sangamitrai will never speak. Sangamitrai, can you read these three equations fastly? Just I want to see that how perfectly you read. Can you read?
V is equal to A plus
Sir.
N plus AT.
Yes.
S is equal to UT half
UT
AT
plus half AT square. UT plus half AT square. Third one.
2AS is equal to V square minus U square.
Very good, very good. Super. That is what. So all of you take the pencil, pen and all. Pen also you have to sum the graph. So please draw the graph. Graph is very important to derive the equation of motion. And tell me from the equation, see that body is starting from position A, whose initial velocity is not 0. It's already having some initial velocity U. So means body is having initial velocity 0 or not 0? That is what my question.
Not zero.
Not 0. So it is already having some initial velocity. Okay, so be very careful. Is it okay, everyone?
Yes, sir.
Yeah, draw the graph very perfectly. How neatly I will draw. Same way, take the scale and you have to draw it. Any doubt, anybody can ask you. Graph is very important. For all the three equations, graph is very important. Okay, Rah, Lingesh? So, body is not traveling with 0 velocity. Already body is having some initial velocity. Let me take that body is already having some initial velocity. So just represent that. I will take it. Format, take it outline. Let me take the red color and thickness also I'll take. Weight also, can I put it? That is clear, Amare? So body's initial velocity is not 0, already having some initial velocity. Understand, everybody?
Yes, sir.
Yes. So already body initial velocity is there. What is the initial velocity we have taken? Here you see. What is the initial velocity? U. Clear?
You.
From there, body is in what motion? Uniformly accelerated motion.
Accelerated.
Means from there it will be what? Linear graph. Is it okay, wa? Everybody clear? Yes or no?
Yes, sir.
Yes. Others?
Yes, sir.
Yeah. From there it is uniformly accelerated motion. Anyone having any doubt, kindly let me know. Is it okay, guys? Yes, that is the statement. Okay. Now observe very carefully. So this is the point A. This is the point A and this is the point B. Now we all know for finding whatever it is, slope, distance, displacement, we have to extend towards to the x-axis and as well as towards to the what axis? All of you?
Y-axis.
Y-axis. Shall we extend it now? Mari?
Yes, sir.
Yes.
Yes, sir.
Now, all of you see. Sanjay, body's velocity is not zero. If it is body starting from rest, the linear graph will come where, guys? From here it will start. Yes or no? Everybody? If the body is starting from rest, the graph will come from here. Is it okay, guys? But body velocity is not zero. Body is already having some initial velocity. So that is why, what is this? Is it zero or not zero? It is not zero. Understand, Sanjay? Body is not starting from origin, Sanjay. Body is starting from point A, where already having some initial velocity. Will you accept it, Sanjay? What I am saying? Understood, Sanjay? If a body is starting from zero, from here graph will start. Body is starting from certain point A, where initial velocity is not zero. Already body having some velocity. Is it okay, guys? Will you accept it, everybody? Please respond.
Yes, sir.
Yes.
Sir.
Sanjay, any doubt, Sanjay? Okay, Mari?
Yes, sir.
Yeah. So what is the initial velocity? U. Okay, va? Everybody?
Yes, sir.
Yes. Next. We will extend towards the x-axis and we'll extend towards the y-axis. You should extend. I should not. So I'm extending towards the x-axis. Now tell me, what is this will give you at this point? You will get something. Can you tell me initial velocity? So we want to find what is this velocity? Graph. Check it, everybody. What is this velocity will come?
Sir, final velocity.
Final velocity, man. Very good, man. It will come you what? Everybody? It will
Final
give
velocity.
you final velocity. Clear? All of you. And we have to extend towards the what axis also? We have to extend
X-axis.
towards to the x-axis also. Any doubt, anybody can ask me. So this is what it is. Extending towards the graph drawing is very, very important. Dotted lines. So can you tell me? So let me take this point is A. I have taken this point is B. Then towards to the time axis. This point I will take it as a what? Everybody respond. Yes, please. C. Clear?
Yes,
Yes.
sir.
Yes. Then
But in the question you gave after time T1, sir.
after time T1 only, Mari. Time T1, time T2. So yeah. So this is the
Yes,
time.
sir.
Total time is OC. Is it okay, Mari? This is the time axis. Clear? Understood? Now, body is already having some initial velocity. The velocity is not zero. So that can I imagine here also one line? Just imagine that. Can I imagine the here also one line? Everybody? Will you accept it? Yes, please.
Yes, sir.
Yes. Body's velocity is not zero. So can I imagine here line or not? Mari?
Yes, sir.
Yes, sir.
Yes. And here, can you tell me what is the angle here? Anybody? What is the angle here? Right angle triangle. See that? What is the angle?
90 degree.
90 degree. Let me take that point is D. Any doubt? Anybody can ask. Are you all clear? Yes. And this point, let me
Yes,
ask
sir.
you. Y and this point is E. I will take it. So now, who will tell me the final velocity in the graph representation, like a trigonometry? Tan theta is equals to BD by AD, like that will represent, correct? Can you tell me who is the final velocity here? Velocity meter per second. Can you tell me who is the final velocity here? This is the final velocity. What is that point? What is the final velocity?
E, sir. E.
E means B. Both are parallel, correct, Mari? Instead of E, I can
Yes,
say
sir.
B, or B, I can say E. Yes or no?
Yes, sir.
Yes, sir.
Yes,
E.
everybody? Yes. That is what? E is the final velocity. Means from where to where? From O to E is the final velocity. Yes or no? Everybody?
Yes, sir.
O to E is the final velocity. Is it okay, guys?
Yes, sir. Sir,
Yeah.
but in between initial velocity is also there, no, sir?
Yes, Mari. That is what total velocity. Total velocity is equals to finally this point only, correct? This whole thing is called as final velocity. Yes or no?
Yes, sir.
Understood, Mari? You want, you can
Yes,
take
sir.
it. This is the final velocity. So what is the final velocity? Mathematical representation. I know final velocity is V, but what is the here graph representing? What is the final velocity representing? Here, check it. This is what we used to say final velocity. So what is that? What is that point? V. Final velocity is what, guys? V here. Okay. So what is that V? Anybody can tell me? BD.
V is the final velocity.
BC is the final velocity. Clear? Lingesh? Final velocity, Lingesh. Initial velocity is OA. See that. Initial velocity is what? What is the initial velocity of the body?
OA, sir.
OA is the initial velocity of the body. Then what is the final velocity of the body? Extending towards the x-axis and y-axis. What is the final velocity?
B.
BC. B is the final velocity. So BC. BC is the final velocity. Or BC is parallel to somebody. Who is that? BC is parallel to what?
B. E.
BC. BC is parallel to what?
EO.
EO. So that is the final velocity. Understood?
Sir, we can write on that side itself. No, sir. E is equal.
You can write, Mari.
In the E
You
place
can
itself,
write
we
here
can
or
write
here.
E of
Your
the-
choice, Mari. Of course, Mari, you can write. EO is parallel to BC. So that EO is equals to final velocity. Means in the sense of BC is equals to also what, Mari? Final velocity. Is it okay? Wa? Understood, Mari?
Yes.
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 Are you understand? Everybody, please respond. Yes.
Yes,
Next,
sir.
same way, use your brain and tell me some other also parallel to some other in the graph. Can you tell me who is that? Before itself, I am saying you. You should tell me.
Sir,
OA is parallel to somebody.
DA and BE.
OA is parallel to somebody. Can you tell me? OA is
DC.
parallel to
DC.
DC.
DC, sir.
So means OA is equals to what? OA is equals to what? Kishore,
Initial
velocity.
D is the intersecting point because body is already having some initial velocity. So I am imagining one imaginary line here. That point is D. Is it okay, Kishore? Okay. So now OA means what, guys? OA means what? Initial velocity.
Initial
So can I say DC is equals to also what?
initial
Equals
velocity.
to also what? Everybody.
Initial
Initial
velocity.
velocity. Understand? Kishore, final velocity is BC and D is the midpoint of BC. Is it okay, Kishore?
Yes, sir.
Yeah. Next, one more line is parallel. Can you tell me from the graph? One more line is parallel.
Sir,
AD.
AD and EB.
AD, EB ille, up ille, mela, down, kila. AD is parallel to. AD is
Sir, why
parallel
can't we say A?
Mari, we want a down correct, Mari. Time axis. This is time axis, Mari. This is velocity.
AD
Understood? AD is parallel to OC. Sanjay, can you tell me OC is equals to what, Sanjay? OC is equals to what?
Time.
Time. So OC is equals to time means AD equals to also what?
Time.
Time.
Yeah, please learn these three things. EO is parallel to BC, so that EO is final velocity. So initial BC is also final velocity.
One doubt, sir.
Yes, ask.
AD and EB are parallel, sir.
Yes, AD and EB also parallel. You want, you can take it. Whatever it is, time only, correct, Mari? Yes or no? But we don't have any
Yes,
use
sir.
of EB. That is why we are not taking. Purima.
Yes, sir.
Understand, Mari?
Yes, sir.
Yeah. So please remember, for deriving three equations of motion, this is the graph we need. Body is not starting from zero. Body is already having some initial velocity u, and then it is going with what velocity? Uniformly accelerated motion. Do you all understand, everybody? Please respond. Body's
Yes, sir.
velocity is not zero. From the point A, then it is traveling what? Uniformly accelerated motion. Pranav, understand, Pranav? Yes, Kishore. D point is the imaginary line I am assuming at point A. Is it okay, Kishore?
Yes, sir.
Yeah, just nothing. As we know, displacement, how to find displacement, guys? Can you tell me? Yesterday's class. Agalya, how to find displacement? Area under this graph. Yes or no? Yes.
Yes, sir.
So for that purpose only I have taken that. Okay, everybody clear?
Yes, sir.
Yes, that is what. So let derive now
Yes, sir.
first equation of motion. We have only 2 minutes time. So let us derive first equation of motion. Everybody observe very carefully. Deriving the first equation of motion, or else you can write derivation of, very simple, guys. Graph you understand, over. Derivation of first equation of motion. Derivation of first equation of motion. Very simple, right? Consider the graph of uniformly accelerated motion. Consider the graph of uniformly accelerated motion. Uniformly accelerated motion shown in the above figure. Shown in the above figure. Now, what is that figure? Can you tell me? Uniformly accelerated motion. What is the name of that uniformly accelerated motion? Everybody, the graph is a what line? Uniformly accelerated
Linear
motion.
line.
Yeah, AB is a what line actually? It is a straight line or curved line?
Straight line.
Okay, a graph is a straight line. Straight line AB. So for deriving first equation of motion, we have to take what, guys? We have to consider the uniformly accelerated motion in the given figure, that is a graph of straight line AB. Okay. Now, so what is the first equation of motion? Can you tell me? We know that the slope of VT graph will give you what? Slope of VT graph. Forget about this part. Only see upper part. Slope of VT graph will give you what? Anybody? Slope of VT graph. Slope of VT graph will gives you what? Velocity time graph, guys. Very, very bad. Last 3-4 days we are studying the same thing. Velocity time graph will gives you what? Slope of velocity time graph.
Sir, acceleration, sir.
That is only I am asking. We know that, right? The slope of velocity time graph, VT graph. VT graph means what, guys? Everybody, VT graph means what? Velocity time
Velocity.
graph.
Velocity time graph.
What it will give, guys? Acceleration.
Acceleration.
Okay, that is what. So I will take acceleration is equals to what? Slope of which graph? Slope of, we have considered what?